Jaltest SST is a small portable device for checking passive and active sensors. There are passive sensors such as inductive sensors and active sensors such as Hall effect sensors. The equipment consists of the case itself and inside the SST device, an electronic device, a set of cables and pins for the proper connection to the different components and control units, and a quick instruction guide for the use of the device. In the electronic device we can find diverse inputs for the electrical connections, one main switch or button for turning on, turning off, changing and confirming the mode, and several LEDs that will indicate the sort of the sensor we are checking, active or passive, different errors that can be detected if any, and another LED which indicates the status of the signal. Finally, another LED that will indicate when the battery is low. Next, we will perform tests with Jaltest SST in a passive sensor of a Renault Premium Dxi, specifically in the inductive speed sensor for the front left wheel. The first step will be to locate the component in the vehicle. To do so, we employ the Jaltest diagnostic tool. We select the type of vehicle truck, the brand of the vehicle Renault. The model will be Premium Dxi in this case. We access the brake control unit and look at the components within the wiring diagram. This is a 4 wheels 2 wheels drive configuration. We access the configuration and within it we will look for the speed sensor. In this case the component is CC007, which is, as we can see, connected to the EBS front modulator. Located at the front left of the cabin as shown in the additional information. As it is a passive sensor, we have to connect the cables, the positive one and the signal to the SST device, and use at the other end the most suitable multi-pins for the sensor pinout. To check if the sensor has an error, we will turn on the device by pressing once on the main button. We will make 2 short keystrokes, and we will access to the read mode of the passive sensor by pressing 2 seconds. In this case, we will be checking that no error is detected in the sensor. To check if Jaltest SST reads a correct signal from the sensor, we will raise the front axle of the vehicle and move the wheel. Once we have the left front wheel free, which corresponds to the sensor we are checking, we can proceed to spin it and check with Jaltest SST how the simulation LEDs are turning on according to the signal that is registered. After checking the correct status of the sensor, we want to send signals of an inductive sensor to the control unit from Jaltest SST. To do this, we change the connections to the control unit, and not to the sensor. We turn the device on, make 4 short keystrokes, and confirm the mode by pressing for 2 seconds. So we can see a signal is already being sent to the control unit at a specific frequency, which we can check in the control unit measurements with the diagnostic tool. To check whether the control unit is correctly receiving the signal sent from the SST, we connect to the brake system with the diagnostic tool. We will go to the measurement reading, in this case the speed sensors of a 4-wheel 2 drive wheel configuration. We will notice that with the sensor disconnected, the measurement corresponding to the left front wheel is showing a value of 7 km per hour. If we modify the frequency of the signal with short keystrokes, we will now be looking at a speed of 28 km per hour. If we increase the frequency again, 43 km per hour. If we increase again, 57 km per hour. For the last time, 88 km per hour. And with the diagnostic tool, we could check that the control unit is successfully registering the simulated signal from the SST. We will then perform tests in an active sensor of a DAF XF105, specifically in the speed sensor of a gearbox output shaft, a sensor with Hall effect. First, we will check in Jaltest the location of the component and the respective pinout to carry out the electrical connections. For the location of the component to be checked, we will use additional information from Jaltest. The first thing will be to select the vehicle model, in this case a DAF XF105. Next, we select the system where that component will be located, in this case the S-tronic gearbox. We check the wiring diagram. Once inside the wiring diagram, in the components list, we'll look for the gearbox speed sensor. We'll select it and will take us to its location and its connection to the control unit. And the physical location of the component in the gearbox. Apart from this, we could observe that other kind of information about the sensor. Positive, ground, and signal. Once the component has been located, we will proceed to make the appropriate electrical connections. First of all, to proceed with the check of the active sensor in read mode, we will turn on the device with a short keystroke. We will press again with a short keystroke and confirm the read mode of active sensor by pressing for 2 seconds. At this point, we will be in the read mode of the active sensor. We can check that no error is detected in the sensor signal. To check if the SST is registering a correct sensor signal, we will have to turn the output shaft of the gearbox. We have noticed that by turning the output shaft of the gearbox, the signal speeds indication LEDs have been changing position, so we can conclude that the sensor is working properly. To simulate an active sensor signal with Jaltest SST on the control unit, we will need to connect the device to the other side of the speed sensor connection. By connecting Jaltest SST to the control unit and simulating a signal from an active sensor, we can check how the measurement corresponding to the output speed sensor of the gearbox varies its value. In the simulation mode of active sensors, to check whether the control unit is registering correctly the signals that are sent from the SST to the control unit. After having all the required electrical connections installed, we will access with the vehicle's ignition on, the vehicle at issue and the corresponding system to take a reading of the measurement that we are simulating. It will be a DAF XF105. The system where the measurement of the gearbox revolution sensor will be astronic. We connect to the system. Once inside, we go to measurements. For instance, in the system display, we will find the measurement, in this case on page 2. And we will see initially that the value marks 0 revolutions per minute. By turning on the SST and starting the proper simulation mode of the active sensor, with 3 short keystrokes, 1 long keystroke to confirm the mode, we will start to simulate a signal at a specific frequency, and then we could be increasing with short keystrokes, seeing how the value changes with each keystroke. In this way, we can confirm that the control unit is correctly receiving a simulated signal from the sensor.